Problem number 13 here is really similar to one that we did in our notes in 3.10. You're dealing with a conical tank with a height of 3 and a radius of 2. Let's see, now a radius of 2 actually means we have a diameter of 4, which means, let's see, then this tank might look something like that if I was trying to get the ratio of things right, but of course that doesn't matter all that much. Okay, what do we have, guys? We just said that our radius here was 2 meters and that our height was going to be 3 meters right there. Now, water flows into the tank at a rate of 2 cubic meters per minute. That right there is a derivative that we were just given, everybody. Cubic meters is a measure of volume, so that's dV. Minutes is a measure of time. So dV dt is equal to 2, and that's cubic meters per minute. What derivative are they asking us to find? How fast is the water level rising? So they want the derivative of our height taken with respect to time at the moment when when that's not minutes, that's meters right there. So when your height is equal to 2 meters. Boy, I looked at that M right there, and for a second I thought it was minutes, so I was about to put T equals 2 minutes. But that's not where we're at right now. Okay, that, I believe, is all the information we were given, everything that we need here. Now, eventually, we need an equation to relate dV dt with dH dt, but first, we need an equation just that relates volume and height. So that's going to be the formula for volume of a cone, which is 1/3, and then the area of its base, which is pi r squared, and then multiplied by its height. Now relax, everybody. If you're bad at geometry and you forgot all your formulas, a formula like this would be given to you on the AP test and also in anything that I give you guys in class, even though I really think you guys are capable of knowing some of those formulas. Now the problem right here with this thing is the presence of that variable right there, r. That is not the derivative that we know. That involves a volume. And it's not the derivative that we want, that's a height. So r is in the way right now, guys. It's crashing the party. So what are we going to do? We're going to substitute this thing, and we're going to solve for r in terms of h. And the way we're going to do that is by looking up here at the original diagram, and we're just going to make a ratio. Whatever order you do this in doesn't matter, but the ratio of radius to height is equal to, and now I look at this problem, when the tank is full, the radius is 2, and the height is 3. So no matter what the water level is in the tank, guys, whether it's right here or whether it's right here or whether it's here or whether the thing is completely full, all of these triangles here end up being similar to each other. And no matter how full the tank is, the ratio of radius to height is always the same. Now, I don't want this r here. I need to get rid of it, which means I'm going to go back to this ratio, this proportion, and I'm going to solve it for r. Easiest way to do that is to just multiply both sides of this equation by h. And I'm going to get r is equal to, and that'll be a 2/3 h. So no matter what the water level is in this tank, its radius is always 2/3 of its height. So that is not a time-specific value right there. That's a ratio that's always true, which means I can make that substitution right here and get volume is equal to 1/3 times pi, and instead of an r, I replace it with 2/3 of the height of the water. Now don't forget to square that after you've made that substitution, and then there's another h that gets multiplied at the end of all that. So, little bit of simplification to do now, guys. The 2/3 gets squared. That's going to make 4/9, which we're going to multiply by 1/3 again. So 4/9 times 1/3 is going to be 4/27. There's still a pi going along for the ride. This h gets squared to make h squared times another h is going to make h cubed. And what you guys have right here is a formula that tells you the volume of water in this tank just in terms of its h value, its height. Now this formula wouldn't work for every single cone that's out there, only in a cone with this ratio right here of its measurements. Only a cone whose radius is always 2/3 of its height will this formula work for. All right, so that's where we're at right now, guys. Let's go ahead and let's take the derivative now of everything with respect to t. So we've got the derivative of volume with respect to time is equal to, Now I'm going to bring that 3 out and multiply it by my coefficient right here of 4/27. Now that would be 12/27, but then I'll divide the 3 out from both of those, and we're going to end up with a 4/9 for that new coefficient right there. The pi just goes along for the ride. We drop the power on h by 1 from 3 to 2, and then we multiply that by a dh dt at the end of all that. So there's our derivative equation, which has 1, 2, 3 unknown or variable quantities. Now, we're looking for dH dt, which means we better know the value of dV dt, which we do right here, and the value of h, which they told us right here. So we're in pretty good shape here, guys. I'm going to move up here to this top right side, and here we go. dV dt is a constant value of 2. That equals, we now have a 4/9 and then a pi. At the moment in question, h is 2. That's a time-specific value, but we can use that because we've already differentiated. Don't forget to square that value right there, 2 squared, and then we're looking for the value of dH dt. So let's clean up that right side a little bit, guys. 2 squared is 4. 4 times 4/9 is going to be 16/9, and a pi is still there, and then a dH dt. Gotcha. What are we going to do now? Let's multiply both sides by the reciprocal of that. So that would be a times 9/16. And remember, this pi is really up here with the 16, so I'm going to put the pi down on the bottom, and we're going to multiply both sides by 9/16 pi. So this 16 cancels with that 16, 9 and 9, pi on the top, pi on the bottom, gone. So our right side now is just dH dt. That's what we're looking for, and this is what I need to put in my calculator here. And it's important that we get this right, guys. The pi is in the denominator. So it's 9/16 pi and then times 2. Let's make sure we're putting that in right. Stacked fraction. So 9 over, we have a 16 pi down in the denominator, and then we will multiply all of that by 2 and end up with, okay, I'm going to go ahead and get that as a decimal then, I think. All right. Yeah, that's what I was looking for. 0.358 would be our answer there, rounded to the nearest thousandth. So 0.358. We're talking about the rate of change of height here, so this is going to be measured in meters per minute. Now, unless the problem specifically says or asks for it, you don't have to give units in your answer there, but that's always a good idea there. I'm looking at the solutions manual. They were not quite as accurate as we were. They've got 0.36. So remember, guys, we always want to go 3 decimal places in preparation for the AP test, so I feel pretty darn good about that answer there for problem 13.